Hey there, I'm Ken Cook, and I'm having another episode. I don't know what sets them off anymore. I think it might be reading. Could be reading. This one I'm especially excited about, though, because I get to talk to scientist Dr. Jabeen Taiba. She's a post-doctoral research associate at the Water, Climate, and Health Program at the University of Nebraska, right out there in the heartland. She's trained as a multidisciplinary researcher with a background in epidemiology, and she has robust experience in clinical research, public health, and manipulating and analyzing large data sets. I'm really tickled to talk to Dr. Taiba today because we're discussing chemical mixtures, and their impact on our health. And this is a thing for me. The question about chemical mixtures is central to our work at EWG. We've published any number of papers as we continue to try and wrap our minds around chemical mixtures in everyday life. Now, just to lay down a framework for you, the official position of the chemical industry and the pesticide industry is that there is really no limit to the number of chemicals that can be added into the world and into us that they should be concerned about. In other words, they want to evaluate them one at a time. If they turn out to be safe by government standards, which is, as you may know by now, if you've been listening, not necessarily EWG standards, then there's no reason you can't add another chemical and another chemical and another chemical. If we don't know anything about the chemical, add that one too. If we know enough about its properties around cancer, but we don't know anything about its properties around what might happen to birth defects or any other health outcome, still add it in. That's their view. I call it, I'm borrowing from Buzz Lightyear here, I hope he'll forgive me, I call it to de minimis and beyond. In other words, we are going to continue to add as many chemicals as a chemical industry to your world and to your body as we possibly can. There should be no limits, and we're never going to look what might happen when they're mixed together. And we know that that's the case. This work is critically important because we're almost never exposed to one chemical at a time. Every day of our lives, from before birth until we die, we're living in a soup of chemicals. Now, additionally, most of the products we use in our everyday lives are also a soup of chemicals in themselves. Personal care products like sunblock and lotion, herbicides that are sprayed on food that end up on our plates, these are usually mixtures of chemicals. And yet our regulatory system evaluates chemicals on a one-by-one basis. Our regulatory system is not assessing the reality of how pervasive chemical mixtures in our lives and in our environment may be affecting us. The reality is, when consumer products are tested, they aren't actually testing the actual final formulation consumers will use, which usually contains a mixture of different chemicals and ingredients. In the case of pesticides, what's being tested are what they call reagent grade versions. Reagent grade means a very high purity version of the principal chemical, maybe something in the range of 95 to 98% pure. So what does that mean to us non-scientists? Well, the government is testing the pure version of an active chemical, but not the actual final formulations that end up on a shelf at your local hardware store or that end up in your body if you're eating something it's been sprayed on. And so if something is sprayed on a farm field, if something is added to a personal care product, the formulation of multiple ingredients has never been tested. We have no idea how these formulations play together and how that will impact your health. Now, at EWG, we've done many tests over the years. Way back in the early 2000s, we found hundreds of chemicals in umbilical cord blood. That's right, babies in the womb. That's hundreds of chemicals that babies were and still are exposed to. What did we find? Well, first of all, PCBs. We've got a lot of data on PCBs and their risk characterizations. We found dioxins. We found certain PFAS forever chemicals. And for some of these, we have a pretty good, not always perfect, but pretty good characterization of how hazardous they are. And from that data, we can begin to infer what health effects might be occurring from those individual chemicals. But what about the combination of them in an infant's body? How do they interact, or do they? Is separate consideration of each one the right way to go? Is it the scientific way to go? It doesn't feel scientific to me to do it that way, but that's the way our regulatory system works. And most importantly, that's the expectation that companies have when they bring a chemical to the marketplace. And if the government isn't looking into chemical mixtures, why would a business bother to do so? Now, I may be a cynic, but one thing the PFAS saga has taught me is that a major corporation will do absolutely anything to keep the blinders on so that they can continue to make a profit, continue to make this stuff, put it out into the environment, put it into products, put it into us. Now, from 2012 to 2015, EWG was honored to work in collaboration with the Halifax Project. That project started when a professor at the University of Halifax had a loved one die from cancer. He came up with this theory that combined low-dose chemical exposures that might collectively cause cancer. But these chemicals weren't considered complete carcinogens in and of themselves, the way we normally think of carcinogens. It was really what happens when they're combined. The Halifax Project started with just one professor and ended up being a collaboration of more than 300 scientists from around the world. While most cancer research focuses on treatment, the Halifax Project and EWG's Rethinking Cancer initiative looked at prevention by reducing people's contact with cancer-causing chemicals. EWG also co-sponsored a symposium at the National Institute of Environmental Health Sciences on chemical mixtures. That was back when friend of the pod, Dr. Linda Birnbaum, was running that institute within the National Institutes of Health. We were thrilled to bring on scientists from the Halifax Project, along with oncologists from all over the country. All in all, this mutual effort with our friends at the Halifax Project and at NIEHS produced a robust set of academic papers that explored what types of chemicals might trigger cancer and how different types of phytochemicals, chemicals that come from plants, might suppress hallmark mechanisms associated with cancer. For us non-scientists, that means a set of traits that explains how normal cells change into deadly cancer cells. My guest today, Dr. Taiba, recently published her study exploring the joint association between agrochemical mixtures and pediatric cancer. Pediatric cancer. I mean, come on. It just takes my breath away saying those words together. The notion of it is beyond horrifying. I'm going to read one sentence from Dr. Taiba and her associates' abstract. Quote, "We observed a statistically significant positive association between 32 agrochemicals, which were all pesticides, and overall pediatric cancer and subtypes of cancer. And the strength of the association was slightly stronger among brain and central nervous system cancers compared to overall cancer." Now, regular listeners of the show know a lot of the chemicals we're talking about by now. It's many of the usual suspects: dicamba, paraquat, glyphosate, the active ingredient in the Bayer Monsanto product Roundup. These are chemicals that EWG has tirelessly worked on, trying to regulate them, encouraging people to use alternatives, or in some cases, completely restrict them. These chemicals are no joke, folks. We just had a barrel of paraquat fall off a truck in Northern California, and it basically caused a small town there to go into lockdown because it is so toxic and dangerous. So, Dr. Taiba, thank you for joining me today. Tell me a little bit about your background and how you came to focus your scientific interest on this particular aspect of environmental health that drives me crazy, the whole question of chemical mixtures and the risk they pose to us.
Thank you, Ken, first for having me here. So, by profession, I am like a clinician. So, I was a dentist back home in India. So, that's where my science or biomedical background
Ah,
comes from. So, I was always passionate about improving health from like oral health to that's what made me think on a
yeah,
broader scope of like a public health. So, I studied
fascinating.
epidemiology, and while I was working at Cincinnati Children's Hospital as a clinical research coordinator, I had like a more broader exposure to different kinds of diseases and conditions. So
Yeah.
cancer was always a priority to me. like prevention. So, coming to the pediatric cancer, as you know, Nebraska is a heartland of the US. Like a lot
Yes.
of the corn and soybean is produced here. But also, Nebraska also has a very higher pediatric cancer incidence.
Yes, I was aware of that.
So, compared to the US average population, so that's what motivated me to study pediatric cancer. My mentor, she is an expert who was working on waterborne chemicals, Dr. Elena Rogan. So, she
Yes.
is a chemist and she is known for her work in chemistry and carcinogenesis, DNA adducts. So, there was a pesticide issue, pesticide contamination issue here while I was working on these. So that was about the contamination of neonicotinoids, which were like replacement OPs from
Yeah.
the
Yeah.
seed corn accumulation and all that. So that paved a pathway to study pesticides further. And also, pesticide mixtures is an important area of research. Like my mentors group was already working on like individual chemicals. They were looking
Yes.
at water contamination or like atrazine and nitrate
Right.
because
Yes.
that contamination is also high in Nebraska.
Yes, and the University of Nebraska Medical Center
Yes,
is highly regarded for this kind of research looking into the relationship between these kinds of
yes.
exposures and health outcomes. So renowned. So you landed in the right place. I just have to go back and say, from a scientist perspective, say a little bit about the difficulty and the different ways people have tried to study mixtures. We know from the CDC biomonitoring program, we know from any number of other studies that we find the mixtures in people already. So we know the exposures are happening. We found, dozens of carcinogens, dozens of neurotoxins, dozens of chemicals that are known to affect our hormones. We found those in umbilical cord blood. So it starts before we
Yes,
come into the world.
yes.
But why is it so difficult? Talk through some of the complications of trying to understand and why it's relatively easier to study one chemical at a time, challenging as it is. Miles easier to do that than to even look at two or three substances, right? All the variations you'd have to look at. Can you say a little bit about that?
Sure. When we are doing like biomarker studies as the CDC's biomonitoring program,
No.
yes, that's a wonderful program. They have measured so many different chemicals, but some pesticides were measured, but like
Mm-hmm.
we don't have like very consistent information. I mean, from my perspective, one reason I could think of is when compared to PFAS or a PBD, some of these chemicals like pesticides, their biotransformation is like much faster. Like sometimes, it's hard to measure them because of
Yeah.
their half-lives, short
In the
half-lives
body,
in the body.
you eliminate
Yes.
them pretty quickly. Yeah. Mm-hmm.
So that could be one of the challenging thing. And also to measure pesticides in biological samples. Again,
Also challenging.
it's not cost effective. I mean, there are like so many studies that have already done mixtures using different chemicals and different outcomes like neurological outcomes or
Right.
like other hormone or like other health outcomes. But not a lot has been done in cancer, but that's, I think, a more upcoming area.
Yeah. Yeah.
Even our own research group, we are pursuing further by considering like biomonitoring or like even using the prenatal fetal blood spots.
Yeah.
Our group is trying to explore those and measuring the pesticides in another way. The challenge is, for example, like atrazine, if you measure in urine or like blood serum, we might not find.
It might be gone already.
It's already eliminated. Yeah.
Yeah, already eliminated in the waste stream. And so then the question is, well, what did it have any effect before it was eliminated? And it's hard to pinpoint that. And also, if only we were worried about exposures to pesticides in Nebraska and other agricultural dominant areas, but there's all the other things we're exposed to as
Yes.
well that might have similar health endpoints. And by health endpoints, I mean like cancer or some sort of neurological
Mhm.
problem. And so to take on something like this, to me, what's so important about it is the potential impact of mixtures was not a consideration for bringing these materials to market, getting them into commerce, and having them end up in people. None of those scientific mysteries were explored before the introduction, and they end up not just in the environment, in our air, our water, our food, but in us. So first you looked at, I guess, the exposure factor, which is the U.S. Geological Survey's data collection on pesticide use, right? Say a little bit about that
Sure.
data set. In California, talking to you from California, we have really robust pesticide record keeping data.
Yes.
We have used that actually to do some studies of our own looking at chemical mixtures. But the rest of the country, not so much. So say a little bit about this data set, what its strengths are, and some of its shortcomings.
Yes, I think US Geological Society's like Pesticide National Synthesis Project, that's like a wonderful publicly available data. You can just download it free of cost. And that data set, it has about 500 active ingredients of these pesticides that are applied on the US croplands on a county scale, actually.
Hmm.
So if someone is considering to study on a county scale, and if they're interested in a larger geographical population like for US, it's a very nice source of data, I would say. The
Right.
drawback is currently the data is only available until 2019. Previously it was like released annually, but I think
Yes.
now they have made some changes to that.
Yeah.
And this data set is more for someone who is doing an ecological study, but it's not very granular because, exposure differs between county level to the census tract and census block, and
Yes.
it
Yes.
differs. So that's one of the drawbacks.
Yeah. It's not detailed enough to go super local. Hmm.
Yeah, but still, it's like a good
Yeah.
resource.
And it's pretty much all we have. I mean,
Yes.
on the agricultural pesticide front, which it's been a theme of some of the podcasts I've done with other researchers, that, we start off needing more data. And if there are steps that are being taken that reduce what's available, no matter what the field, that's concerning, because that means we don't have the ability to look at some of these basic questions without the underlying data.
Yes.
People don't want that data out there. I think there's a public interest in continuing to fund that function at the government level. Okay, so you got the data on pesticide usage
Yes.
from USGS. What was the next step to look at the relationship between that and various pediatric cancer outcomes? What did you have to do?
So this data set has about 500 type of active pesticide ingredients.
Let's make note of that. 500.
Yes. Yes.
500.
But my goal was to select some top pesticides, that were consistently applied across my study time. For example, over a period of like 22 years,
Yeah.
I wanted to
Yeah.
make sure these pesticides have been applied every year, and also these were applied across the 93 Nebraska counties. So that was
Yes.
the criteria that I developed to select the top chemicals. So based upon this criteria, they have to be applied at least across 90% of my timeline, which is they have to be applied at least 20 years.
Yeah. So you have a lengthy period of time during which
Yes.
a lot of babies would have been born in those counties, I presume. And when you started off selecting the pesticides, did you select pesticides that had shown in lab studies or other ways that they were carcinogenic, or did you just look at all of them?
No, I just looked at all of them because my study was not from a toxicological perspective. It was more from an ecological and a
Yeah.
mixtures
Yeah.
perspective. My criteria was they have to be applied consistently across the timeline and in all the Nebraska counties. So
Yeah.
based on that, I identified 32 pesticides were consistently applied for this longer period. And these were like herbicides dominant,
Weed killers. Yeah.
followed by insecticides. Yes.
Yeah. Yeah. And so Then you looked at a whole series of factors. You looked at race, you looked at income, employment, access to care, which that seems so important in determining diagnoses. So where did those data come from?
So those data, I would call it social vulnerability. Yes, that came from the US Census
Yeah,
Bureau, and that is again a publicly available data. And I did not really look into individual factors, but
right.
we have adjusted for those covariates in our model actually.
You had to build a model, which I'm going to read it out because my audience probably won't. Not sure I understand it even reading it. Generalized weighted quantile sum regression model. Wow, that's a mouthful. Now, how, how, tell me what happens inside
Sure.
that model.
So this is one of the very advanced mixture model. There are different types of mixtures models, and depending upon your research question, you can choose the model. So this it not only helps us to understand the overall effect of that chemical mixture, but it also helps us to identify the potential chemicals that would have caused that joint association.
The ones that are driving the estimates. Yeah, the outcomes.
So
Yeah.
this model is very helpful for that.
So you dump the chemicals into the model, and the model already has all the characteristics
Yes.
of the pediatric health outcomes and the
Yes.
socio-demographic factors.
So what it does is it creates an index of all these chemicals. So that's the first step how this model works. And then depending upon your outcome, like whichever cancer outcome you're selecting, it would look at the association between that weighted index and that specific cancer types while adjusting for some of the covariates that we talked about, the
Yeah.
race, income, and all that. Because all our data, the cancer cases, it's like a number, it's a count data. So this model, what it does is it divides those cancer cases by offsetting it with the pediatric population for that specific county. So it gives us a rate actually of what would be the rate of the pesticide mixture for that specific cancer type.
Yeah. So how does the model figure out the association by cancer type? And you mentioned in the paper that the slightly stronger for cancers of the brain, pediatric cancers of the brain. I don't even want to think about it. And also of the central nervous system, CNS cancers. How does the model help you figure out and focus on the specific cancers?
So for each cancer type, this model looks at those joint associations and it gives us a 95% confidence interval. So for
Hmm.
each, it gives that. So based upon those numbers, based upon those estimates,
Hmm.
we would identify which cancer had that slightly higher association compared to the other cancer types. We run this model for every cancer type, actually. And then that's how, based upon those estimates, we identify which is higher.
Yeah, relatively elevated. And you're also able to identify the specific pesticides. And the top
Chemicals.
three are weed killers, dicamba, glyphosate, and paraquat. When you stand back and look at it, what questions come to your mind that we should be thinking about in the real world? This is a model, and I know your paper is fastidious in talking about its limitations. So I'm
Yes.
very aware of that, and I don't want to overstate beyond what your model claims either. But still, what do you say about how we should be thinking about this? And what we've been telling people for a long time is we shouldn't just accept that it's a mystery what mixtures might be doing. We should be exploring what they might be doing and then ask ourselves, well, is our policy system, is our regulatory system, is the way these things are used in the real world, are we really taking account of mixture effects? And should we take steps to avoid some of these exposures? What does this tell us about how we might want to change the regulatory system or change behavior? If you're talking to a farmer, talking to a farm family with a pregnant
Yes.
farm wife, how do you approach that question?
That's a very, very good question, Ken. I mean, yes, these results could be still data driven. Like, these are not like coming from a biomonitoring
Right, right.
standpoint or something, but still, I'm not talking that exposure to these chemicals is causing this.
Right. It's an association.
Yeah,
Hmm.
it's just a association. I'm not talking about the biological pathways or causation.
Yeah.
However, any kind of environmental exposure, be it with a larger dose or a smaller dose, because dose is not the important thing, right? Because sometimes
Right.
even the smaller exposure could cause a larger effect.
We've talked about this. I talked about it at length with Philippe Grandjean, who wrote a great paper on the dose makes the poison notion. And,
Yes.
it turns out that the timing of the exposure, in this case, an infant developing in the womb or an
Yes.
infant just been born, more vulnerable, the timing, the fact that the receiver of
Yes.
the dose is a smaller person, and then sometimes certain types of cancers we have reason to believe might be more susceptible to being triggered by mixtures. So
Yes.
it's all of those things, right? So
Yes.
it argues for caution, I think.
Yes, it argues for caution. I would, if I am to talk to a farmer's family or someone working in ag, I
Yeah.
would still tell them to be cautious, to use all the personal protective equipment possible. And yes, because we are talking about the critical windows of exposure, that's very important, right? For
Yeah.
any disease, not only for cancer, critical windows of exposure, because exposures happen before birth,
Yes.
prenatal exposure. So, yes, it's always safe to be cautious about any chemical.
Yeah. And, if you're in farm country, it might be in your drinking water,
Yes, drinking water, the food we eat. Yes,
might be in air
yes,
drifting from fields. I
yes,
mean, I've spent a lot of time on farms, grew up on my uncle's farms, went to graduate school at the University of Missouri in soil science. And one of my professors on my master's committee was studying no-till farming. This was in the 1970s. So going back a ways. And of course, the whole question was if we're going to rely more on chemicals, particularly weed killers, to eliminate the need for tillage,
yes,
field work to make it more efficient and faster. One farmer on a big piece of equipment, a spray rig and planter rig combined, can cover a lot more acreage than 30 years ago when they had to go in and prepare the seed bed in much more granular, literally granular detail. So it is a concern. And even with the Maha Commission, the first report that came out, they referenced mixtures that suggested that they needed to look at that. There's been considerable resistance to looking at mixtures. I haven't seen any pesticide companies come forth and sort of openly say, hey, maybe we should look at mixtures of chemicals that are produced by my company and 5 other companies and see what that might mean. That's not a conversation I've ever heard the industry suggest should be started. And so, there's inherently looking at these exposures in relation to any health outcome. There's going to be controversy, and you're in Nebraska. So let me ask you, what is next? Are you going to be following up on this? And specifically, I was wondering if this same methodology, it seemed to me it could be related to other types of health risks, neurodevelopmental disorders, for example, or endocrine disruption, whatever. It seems like the model would be
yes.
suitable to that. But what's your next big thing?
So mixtures is like I'm very passionate about working on mixtures.
Yes, stick with the mixtures. Go, you go.
So I am in currently I am studying about endocrine disrupting chemicals, and that's
Okay.
about female reproductive outcomes. So that's
Yeah.
my next area. In addition to the pediatric environmental health, I am expanding to the female reproductive health.
Oh, fantastic. Well, congratulations. I can't wait to see what you come up with next. Thank you for spending some time with us and diving into the details of your really exciting and important study. I'm thrilled to have had a chance to talk to you. Thanks again, Doctor.
Thank you.
Thank you so much for listening. If you'd like to learn more, be sure to check out our show notes for additional links to take a deeper dive into today's discussion. Make sure to follow our show on Instagram at Ken Cook's Podcast. And if you're interested in learning more about EWG, head on over to ewg.org or check out the EWG Instagram account at Environmental Working Group. Now, if this episode resonated with you or you think someone you know would benefit from it, please send it along. The best way to make positive change is to start as a community with your community. Today's episode was produced by the extraordinary Beth Rowe and Mary Kelly. Our show's theme music is by Moby. Thank you, Moby. And thanks again to all of you for listening.